A contestant on The Biggest Loser is trying to cheat. The contestant weighs 980 newtons on the surface of the earth, but wants to drop down to 900 newtons, so the contestant goes by helicopter to the top of a mountain to lose weight. At what height above the surface will the contestant have a weight of 900 newtons? So, just to draw this out, you've got the contestant for The Biggest Loser standing on the ground, and then that same person goes to the top of a mountain. Our given information, and I'm just going to call this A and B. We know that the weight at A is 980 newtons, and the weight at B is 900 newtons. And what we're looking for is how high, so the height, I'm going to call that H, that this person has to go in order to weigh 900 newtons. So if you recall, your weight, Fg, equals mg, can only change if one of two things happens. First, your mass has to change. Second, g has to change. For The Biggest Loser contestant, if they're trying to cheat, they're not going to be changing their mass. So what they're doing is trying to change g by going up high. And g is directly dependent on how far away you are from the surface of the earth. So what we're going to do is look at what happens in order to change this g and then figure out what that height is. So the first thing we want to do is figure out what the mass of the person is. We know that mass is equal to weight over g. So the mass of the person, we already know what g is on the surface of the earth, would be 980 newtons divided by 9.8 meters per second squared. 980 divided by 9.8, this is an even 100 kilograms. So knowing that the mass of the person is 100 kilograms, we can figure out what their acceleration due to gravity, or little g, is at the top of the mountain. So taking their weight divided by the mass, we'll be able to figure out what little g is at the top of the mountain. So this is 900 newtons divided by 100 kilograms. So at the top of the mountain, g has changed to 9 newtons per kilogram. So now we know what the g, and I'm just going to call this at point B. We know what the g at point B is, we know what the mass is. Let's see how this all relates to gravitational attraction to figure out what this height is. As the person is on the top of the mountain, we can say that their force of gravitational attraction is equal to their weight. So this means that g, m1, m2, over r squared equals mg. Now since this is the mass of the person in the mg, I'm just going to make that 1. It doesn't matter if it's 1 or 2, but on both sides of the equation the mass of the person is canceling out. So g m2 over r squared equals little g. Remember, r is the distance between the two objects center to center, and r includes the height. So the r will be equal to the radius of the earth plus the height. I'm going to keep it as r for now, just to make the solving a little bit easier. So let's isolate r. We get g m2 over g equaling r squared. So g being the universal gravitation constant, m2, which is the mass of the earth, over little g equals my r squared. So in your calculator, gm divided by, and this is the g at point B at the top of the mountain, so this is 9 newtons per kilogram, equals r squared. Putting those numbers in, you should get 4.43, keeps on going, times 10 to the 13th meters squared equaling r squared. Taking the square root of that, 6.65, keeps on going, times 10 to the 6th meters equals r. So r equaled the radius of the earth plus the height, which means that r minus the radius of the earth equals my height. So 6.65 keeps on going, times 10 to the 6th meters, minus the radius of the Earth, gives me height. This comes out to 278,706.9, keeps on going, meters. With 1 sig fig, the mountain has to be approximately 300,000 meters above the surface of the Earth for that person's weight to change. So that's pretty high. It's pretty significant for the force of gravity to change by that much, but in order to feel only 900 newtons, when in actuality at the surface of the Earth you're 980 newtons, you have to get about 300,000 meters above the surface of the Earth.